Hello students, now we'll discuss about temperature dependence of resistance and resistivity. What is the effect of temperature on resistance and resistivity? Now, as in the previous lecture what we have studied, we have found out the formula for resistance, that was ml upon Ne square tau A. If you we have also studied about the formula for resistivity, that was m upon Ne square tau. This can be made from here also. Here what we can do, we can remove L by A and rest of the terms, and we know that formula R is directly proportional to L by A and the proportionality constant is rho, and that is resistivity. So this term becomes resistivity. Okay, so in short these are the two terms, one is this and one is this, which shows the resistance and resistivity. Okay, let us once again revise the terms that were used inside it. What is m over here? M is nothing but mass of electron. Okay, what is the length and what is L? L is the length of the conductor along which the current flows. Okay, next N is number of free electrons per unit volume. Okay, I repeat once again, free electrons. N is number of free electrons per volume. What are the free electrons? Free electrons are the electrons that keep on moving which contain the charge. Okay, there may be other electrons also other than free electrons which are not yet ionized. In any atom there are always electrons, protons and neutrons, which means that is a neutral atom, but there are free electrons in a conductor. Okay, so this N is number of free electrons. E is charge on electron. T is average relaxation time. What is average relaxation time? Suppose we have a electron over here, it goes here, again collides with an ion, again collides with an ion, again collides with an ion. Okay, so what happens over here? The time between the collision is relaxation time, and what we take the average of all the collisions that it is taking. So in short we are writing tau, that is average relaxation time for total number of collisions. Okay, next, a cross section of area perpendicular to the current. In this example what we had studied was the area of this, that was current was flowing in this direction, so the area perpendicular to this. Okay, this was the perpendicular area. Okay, so this was the cross section area that we were considering. I hope this is just a revision and you all are knowing about it. Okay, so now what we will do, we will study about temperature dependence on different materials. First of all we'll study about conductors. Okay, now what happens in conductors due to increase in temperature? Just think of it and then we'll go ahead. I'll give you just a few seconds, think of it. You can pause the video and think of it. Okay, I'll tell you. If temperature goes up, okay, temperature goes up, what happens? It will increase the kinetic energy. If the temperature goes up, it will increase the kinetic energy. Okay, due to increase in kinetic energy, what will happen? The vibration of the electrons will increase, the motion of the electrons will increase. Due to that, the collision will be very frequent. Okay, I'll write down, vibration increases or kinetic energy increases. Kinetic energy increases. Okay, due to this, number of collisions increases, or you can say the frequency of collision increases. The time between the two collision, that is relaxation time, decreases. Relaxation time tau decreases. Okay, relaxation time decreases. Okay, so what happens if the relaxation time decreases? Okay, I'll write down the formula once again over here. For R equals to what? R equals to ml upon Ne square tau A. Okay, so from this what can you say, what happens to resistance? If tau decreases, means tau decreases. If tau increases, what will happen to resistance? It will increase. As the value of this decreases, what will happen? With decrease in relaxation time, resistance will increase. Okay. Similarly, if I write formula for resistivity, it will be m upon n e square tau. It will be similar for rho also. As relaxation time decreases, resistivity increases. Okay. This is one condition. Okay. Now, if the temperature increases, then ionization will also increase. Ionization will also increase. Okay. If temperature increases, ionization also increases. Due to ionization, what happens? Number of free electrons will increase. Okay. N will increase. Number of free electrons increase. Okay. Due to that, N will increase. Now what happens due to N? If N increases in both the cases, both will decrease. Okay. If N increases, R will also decrease and N will also decrease. Okay. So but now one term increases the resistance and one term decreases the resistance. So what to do now? We need to find what is important, what is significant. Okay. Now here, number of free electrons in a metal conductor. Okay. In a conductor is to the range of 10 raised to 20. That is a very huge number. Now if the temperature increases and increases the number of free electrons, that will be negligible compared to this. So this becomes insignificant. Insignificant. Okay. Though there will be effect of this, but it will be very negligible, or you can say negligible. The effect due to this would be negligible. So what we can do? We can ignore this part. We can consider this part. So this will be our significant. Okay. So this becomes our significant partition, main thing. So when the temperature increases, the resistance will increase and resistivity will also increase in case of conductors. Now we'll take second type, that is semiconductors. Semiconductors. Okay. Now same thing for semiconductors. What happens? As temperature increases, vibration will increase, and similarly everything will take place. Temperature increases, vibration increases, relaxation time decreases. Okay. Now I'm shortly writing it because you already know. Okay, I'll show you. Yeah, it is visible through this. Resistivity increases and resistance both increase. Okay. Here what happens? Second part, N. Ionization increases. Okay. So N increases, R decreases, and rho also decreases. Okay. Sorry. Okay. Now here in this case what happens? The vibration, here the number of ions or free electrons are very less in semiconductor. Okay. So as soon as you increase the temperature, what happens? Ionization increases very rapidly, which increases this with a very huge number. Here N is very large. When we had compared it to conductor, it was very less, but here N is very large. So in this case, what becomes significant is this part. This part becomes significant. Okay, and compared to this part, we can ignore this part. Okay, so I can write insignificant. So what happens in case of semiconductor? As the temperature increases, resistance decreases. Whereas in conductors, it was as the temperature increases, resistance also increased. Okay. Now I shall plot the graph for both the things. I hope this is visible. Okay, I will be plotting graph, one for conductor, one for semiconductor. Okay, let us take is R or rho on this line, and let this be temperature. Okay, similarly here R or rho, resistance or resistivity, and this becomes our temperature. Okay, what happened in the first case? During the conductor, as the temperature increased, resistance also increased. So the graph will come like this. Okay, it will not be a straight line, but it will be a curve. But what happens, as the temperature is increasing, the resistance or resistivity is also increasing. Okay, that was in the case of conductor. Okay, now in the next case, in the case of semiconductor, what happened, as the temperature increased, resistance decreased. So what happens in this case is it comes down. It will be in this manner. Okay, as the temperature increases, resistance goes on decreasing. Okay, now we have one more type. Third are some few only materials. Nichrome. Okay, what does this material do? It has resistance remains almost constant. Resistance remains almost constant with temperature. Okay, sometimes these materials are used in practical things, like if you are doing an experiment, you need to keep the resistance constant. At that time you can use this thing. This doesn't have much of the effect. What happens over here? Tau and n. Decrease in tau will increase in n. Both will compensate each other. Compensate each other. So it will have very less effect on temperature. Very less effect of temperature. If you go on to draw the graph of this R or resistivity with respect to temperature, then what will be? It will be a very near straight line. Okay, it exactly is not remaining constant, but it has very less effect, whereas in other we had a straight curve or like this. Okay, so this is not possible in this case. Here it is almost straight, or it is not changing very much. Okay, I hope this part is very clear. That is what is the dependence of temperature. In conductors, what happens? As the temperature increases, the resistance and resistivity increases, whereas in semiconductors, as the temperature increases, the resistivity and the resistance decreases. Whereas in some materials like nichrome, and there are few others also, here the resistance and resistivity almost remains constant with respect to temperature. Okay, I hope you have got it. Thank you. Have a nice day.